Hello dear students, in this video we are going to discuss some of the important question and answers of first PUC Chemistry chapter Structure of Atom. So in this question we need to find out the number of protons and number of neutrons of iron whose atomic number is 26 and mass number is 56. Atomic number symbol is Z and mass number symbol is A. So atomic number is equal to the number of positive protons and the number of negative electrons. So therefore the number of protons in iron is equal to its atomic number, that is 26. And to find out the number of neutrons, the formula is A minus Z, atomic mass minus atomic number. So atomic number is 56 minus atomic mass is 56 and atomic number is 26. So the number of neutrons in this atom is 30. Then what are isotopes and example? Very important to the exam. Isotopes are the atoms of the same element having same atomic number but different mass number. They are called as isotopes. So isobar definition: isobars are the atoms with same mass number but different atomic number. They are called as isobars. Then question related to quantum numbers are very important. The first quantum number is principal quantum number, small n. Its significance is to determine the size and energy of the orbital. Azimuthal quantum number is small l. Its significance is to find out the shape of the orbitals. And third quantum number is magnetic quantum number. Its significance is to find out the orientation of the orbital. And last, spin quantum number is to find out the spin of the electron, whether it is spinning in clockwise direction or in anti-clockwise direction. Next, very important question is difference between orbit and orbital. Orbit are the circular path around the nucleus where electrons are supposed to move, whereas orbitals are the three-dimensional structures or three-dimensional region around the nucleus where there is a maximum probability of finding the electron is possible. And orbit can accommodate maximum 2n square electrons, whereas orbital can accommodate maximum only 2 electrons. Next, numericals related to wavelength, velocity and frequency are very important. So calculate the frequency of yellow radiation whose wavelength is 5800 Armstrong. So Armstrong we need to convert into meter. They have given 1 Armstrong is equal to 10 to the power of minus 10 meter and velocity is 3 into 10 to the power of 8 meter per second. So we have a formula to find out the frequency. Frequency is equal to velocity c divided by wavelength lambda. So velocity value is standard 3 into 10 to the power of 8 meter per second. Lambda is 5800 Armstrong. So 5800 we have converted into meter by multiplying with 10 to the power of minus 10. So when you calculate the frequency, we will get 5.172 into 10 to the power of 14 per second. We have one more numerical here. The wavelength lambda of red light from beacon's light is 680 nanometer. Calculate the frequency of light. So wavelength is 680 nanometer. We need to convert into meter by multiplying with 10 to the power of minus 9 and velocity 3 into 10 to the power of 8. So velocity is equal to, frequency is equal to velocity divided by wavelength. We will substitute the value of velocity and wavelength. We will get the answer of wavelength in unit per second, 4.411 into 10 to the power of 14 per second. Question related to electronic configuration, very important, especially copper or chromium they are going to ask. So copper and chromium both shows exception kind of electronic configuration. So this is the electronic configuration of copper: 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d9, and chromium shows 4s1, 3d5. So here they are asking the value of principal quantum number n and azimuthal quantum number L. So principal quantum number is equal to highest principal quantum number. So in this electronic configuration, 4 is the highest principal quantum number. So n value is 4, and in last shell electron is entering in s orbital, and s orbital azimuthal quantum number value is 0. Another very important question for 3 marks is postulates of Bohr's atomic model. This model says that electrons are revolving around the nucleus in a definite circular path called orbits, and as long as electrons revolving in a particular orbit, it does not emit any energy, which means it does not lose energy or gain energy. And third postulate, only those orbits are permitted in which angular momentum of electron is integral multiple of h by 2 pi. So these are the important postulates of Bohr's atomic model. Limitations of Bohr's atomic model also very important. The two limitations are Bohr's theory not explain the emission spectrum of atoms having more than one electron. So Bohr's is related to hydrogen. More than one electron containing atoms they have not explained. Then this theory or this model fails to account for the finer details of hydrogen spectrum. Regarding hydrogen spectrum, no explanation. Next very important concept is de Broglie's equation in this chapter. De Broglie formula is wavelength lambda is equal to h Planck's constant divided by m into v. M into v is also called as b, that is momentum. So lambda is wavelength and small m is the mass of the particle and v, capital V, is the velocity of the particle. So mass into velocity can be taken as momentum p. Numericals related to de Broglie's equations are also very important. What will be the wavelength lambda for a ball of mass 0.1 kg? The mass of the ball is 0.1 kg moving with a velocity 10 meter per second. Velocity is 10 meter per second. Planck's constant h is constant. They have given that value. When you substitute and calculate, you will get the wavelength 6.6 into 10 to the power of minus 34 meters. Another 2 marks very important question is Heisenberg uncertainty principle and its formula. So Heisenberg uncertainty principle says that it is impossible to determine simultaneously the exact position and momentum of an electron. Its formula is delta x into delta p greater than equals to h by 4 pi. 2 marks very important. Another very important question from this chapter is Hund's rule of maximum multiplicity. So it says that among the orbitals of same energy, you can find here the p orbitals, px, py, pz. All these three orbitals are having same energy, degenerate orbitals. So among the orbitals of same energy, all these three having same energy, electron do not start pairing. Electron cannot start pairing. For example, p orbital, each orbital capacity is 2 electron. So they will not start pairing until they contains 1 electron each. Until all the orbitals of same energy occupy singly, they will not undergo for pairing. Photoelectric effect is very important. Photoelectric effect means the emission of electrons from the surface of the metal. The surface of the metal start emitting the electrons when they are exposed to the light of suitable frequency. When the metal surface is exposed to suitable frequency light, then the metal start emitting the electrons. That is called as photoelectric effect. And photoelectric effect supports particle nature of the electron. So here they have given one example. When the light of frequency greater than 5 into 10 to the power of 14 hertz falls on potassium metal, it shines due to photoelectric effect. So every metal requires threshold frequency to emit the light. Numericals related to Rydberg constant value, Rydberg equations are very important. Calculate the wave number of spectral line of shortest wavelength appearing in Balmer series. So for Balmer series, N1 value is 2. Like Lyman series, N1 value is 1. Similarly, Balmer series, N1 value is 2. And they are saying shortest wavelength. Shortest wavelength means N2 value is infinity. If they say largest wavelength, then N2 value will be 3. It is shortest wavelength, that's why N2 value is infinity. Now we have a formula 1 by lambda, that is wave number, is equal to Rydberg constant R into 1 by N1 square minus 1 by N2 square. I will substitute the values. R is Rydberg constant. They have given the constant value in the question itself. Substitute 1 by N1 value for Balmer series 2 square minus 1 by N2 square. N2 value is infinity, so that's why 0. So when you calculate, you will get the answer 2.742 into 10 to the power of 6 per meter. So similarly, we have one more numericals related to this Rydberg constant formula to find out the wave number by R is equal to 1 by N1 square minus 1 by N2 square. So that is very important to the exam. So these are some of the important question and answers of second chapter, structure of atom, from first PUC.